Hey guys, this is Mr. Pasco with what should be the second last video from the Networks chapter. And wouldn't it be nice when we finish the chapter to be able to take a holiday to Hamilton Island in Queensland? But sorry, it's not going to happen. We just have to go on and do the next chapter. We're talking about Hamilton Island and Hamiltonian Paths and Cycles. So if you ever do get lucky enough to go to Hamilton Island in the Great Barrier Reef, which is a fantastic part of Australia, I suggest everyone visit at least once in their lifetime. There is a path you can follow around Hamilton Island to visit all the key places in the resort, and that's a Hamiltonian path, and we will tell you why in this lesson. Alright, so the video will flow better when played at higher speeds. I'm a slow talker and not great at using the drawing pens, so make sure you go to the video player bar tools cog, and if you click on that little cog on the player bar, you can go to playback speed and use this arrow and set it to like 1.5, 1.75, or even 2 times speed. And the video will flow a lot better and won't go as long either. And I don't know why that's saying lesson 4B Euler's rule. It should be something else, but we'll have to fix that up. So Hamiltonian Paths and Cycles. There are some nice paths around Hamilton Island. That's what it looks like up at the Great Barrier Reef. It is such a nice place and a part of Australia, but they do get bad storms up there for part of the year, so that's the only drawback. Now the paths, like this lovely path going around here, they visit all the key locations on the island, so it is in fact a Hamiltonian path. Hamiltonian Paths and Hamiltonian Cycles aren't confined just to Hamilton Island. They do happen everywhere in our world. Now, they're similar to the idea of the Euler's trails and circuits that we did in the last lesson, except this time we're not talking about the edges, we're talking about visiting all the vertices once in the network, and we don't really care about the edges. So Euler was all about edges with his trails and circuits. Hamilton, this mathematician, he was all about vertices. So Hamiltonian Paths and Cycles we're doing in this lesson are all about vertices, okay? So Hamiltonian paths, they're used in planning travel for business and pleasure. And also if you got a rock band or a music act you follow to plan their tour and all the flights they need to do. They don't want to be going on long flights between cities. So let's say you needed to get to Madrid here, to Moscow or something. No, that's not a good example. Let's say you need to get from London to Rome. You wouldn't like to be flying from London to Berlin, have some 3-hour boring stopover at the airport, and then fly to Rome, right? Especially if you've already visited Berlin. You'd rather get a direct flight. And that's what we're talking about. We're talking about how could you go on a holiday in Europe and visit all of these capital cities here that are on this map, doing only one flight between each city and only visiting each city once. And my son did a recent big tour of Europe, Eastern Europe, and he had to do this same sort of planning actually, and plan himself a Hamiltonian path to do his trip, combined with was flying and taking buses and trains. So Hamiltonian paths needed to visit all of these vertex cities. But the thing about the path is the path doesn't have to finish back where it started, okay? So we don't have to finish at the same city we're starting at on this tour. So possible Hamiltonian paths are, we could go from London to Berlin and then fly to Paris and down to Madrid, across to Rome, over to Athens, and then finish our trip up in Moscow. So that way we'd only be flying to each city, only visiting each vertex on that network once. So that would work out. Another way you could do it is you could go London down to Madrid if you really wanted some sunshine, because it's nice and warm down there in Spain, and then travel to the beaches and that from Madrid. Then go across to, then go up to Berlin, actually. No, sorry, to Madrid. Then go to Paris in France. Then go up to Berlin. Then to Rome, and then to Athens, and again finish in Moscow. Or you could decide, I need sunshine, so I'm going to start my tour in Madrid and do all of Spain where it's nice and warm. And then after that, I'll go up to Paris. Then I'll go across to Rome. I'll go across down to Athens, and maybe from there go to the Greek islands. Then from Athens, I'm going to take this flight to London. And then I'm going to go to Moscow and then finish up in Berlin. Okay, so there's lots of different Hamiltonian paths you can do. The main thing is that you're making sure you only visit each city once. Like we said, you don't want to take an unnecessary, if you've already been to Paris, you don't want to go back there again on a flight, Madrid to Paris, have some horrible 3 hour, 5 hour stopover or something, then fly to Berlin. Okay, you want to get direct flights everywhere. So that's what we're talking about. So like we said, there's several others. Okay, now Hamiltonian Cycle, that's a cycle I like the look of. That's a Mercedes-Benz electric cycle, so that when you get tired, you can just turn on the electric motor to go up hills. I really want one of them one day, but I don't know, the YouTube views would have to pick up a hell of a lot to be able to get enough money for that. This time we want to visit each capital city once, but we want to start and end at the same city, all right? So this time we're doing what's called a Hamiltonian cycle, but it's a very similar idea. Possible cycles are we could start in London, go to Berlin, then down to Paris, then to Madrid, then across to Rome and to Athens, up to Moscow, and then fly back to London, okay? So that way we started in London and ended at the same place in London, so that's a Hamiltonian cycle. It's very much the same as a path, it's just that we have to make sure we start and end at the same place this time. Another one you could do is London, Madrid, Paris, Berlin, Rome, Athens, Moscow, and back to London. Or you could start in Madrid and go Madrid, Paris, Rome, Athens, London, Moscow, Berlin, and then back to Madrid. And there's plenty of others you could do as well. So doing trips and backpacking around Europe is great fun. I did a little bit of it when I was younger. My son has done a lot of trips to Europe, backpacking and flying and taking trains and buses. And it's much more fun than just sort of, you know, getting a job and then buying a house and having a mortgage to pay and not being able to travel anywhere. So backpacking and travel, highly recommended. Now, Hamiltonian Paths and Cycles. So the path visits all of the vertices, so all of the dots on the network, but it can start and finish at 2 different locations. So we're looking at starting and finishing at 2 different locations when we do a Hamiltonian path, but we have to go to all of the vertice dots on the network. Okay, so in this one here, we can start at A and we go to B, visit dot B, then go to C there, vertice C, go down to vertice D in the corner, and then go across to vertice E, and then we're finished because we've been to everything. We've been to A, B, C, D, and E. So that's a path. We started at A and we ended at E, 2 different locations, okay? Now, to do a Hamiltonian cycle, it's the same thing. We have to make sure we visit all of those vertice dots, but we've got to start and finish at the same place. We can't finish and start at 2 different places. Okay, so for that same network to do a Hamiltonian cycle, we could start at A and go across to B, then we'll go down to E, then we'll go across to D, then we'll go up to C, then we'll go back to A where we started. So we started at A and we've kind of looped around here in a loop, and we've ended up back at A. But during our journey, we have visited every single dot, every single vertex on that network. So that is a Hamiltonian cycle, okay? And plus there's plenty of others too. So for all of these things, there's always more than one answer. We've seen that previously when we did Euler circuits and circuits and trails, okay? So you've got to be careful not to get these mixed up. Euler has the trails and the circuits. Hamilton has the paths and the cycles. Okay, so let's do some questions out of the book here. Question 5, we did this one back when we did Euler stuff, but we were doing an Euler trail. This time we're doing the Hamiltonian path. Now, a Hamiltonian path needs to visit all the vertice dots, but it does not start and finish at the same place, okay? So let's have a look at this first one. Now, the strategy in this is, see this one that's got a high number of connectors, a high number of edges, E, it's got a high degree. And this was our strategy in Euler too, that we wanted to make sure we get to one of these paths pretty quickly. But in a Hamilton path, we kind of want to have this in the middle of our path. So I want to do a couple of things and then get to this one in the middle of the list of vertices we're visiting, and then do the others. So how that strategy works is, we're going to start at B and go up to D, and then pretty quickly, as soon as we can, get down to E. E has lots of lines coming out of it, so there's lots of options for visiting vertices. Just like at a big interchange airport, like Heathrow in London, there's a lot of options for flying to different places and visiting them. So E's kind of like our Heathrow. It's our big airport that has a lot of flights going out to different locations. So we want to head along and get to that big airport pretty quickly. From E, we'll go down to F, and then we'll go to A. So we're using that same thing we did in Euler, where we kind of go around the outside first, and then we do the zigzag one. So then we go up to C, and then we go back to nowhere, because we have visited all the vertices. We've done B, we've done D, E, F, A, and C. So we don't need to go anywhere else. And we started at B, but we ended at C. So we've started and finished at two different places here and visited all the dots. So that's our Hamilton path done for that one. Okay, now the strategy for 5B, there's no kind of outside one we can go round like we did in 5A. You can see from the shape of this network, what it has is kind of horizontal type Z's, zigzags, or what a slalom skier would do. They come down, then they go through the turn across to here. There's another tight turn, then down to here, then down to here. So we'll do the horizontal ones first, and then we concentrate on doing the vertical ones to finish off. So that's our strategy, do the horizontal Z's or zigzags, and then do the vertical ones, okay? So we go from B across to E, then we go to C, then we're heading down to A, and then we're heading up to D. So we've done a couple of horizontal zigzags, right? Now we're doing the vertical ones. We're going from C to A, then up to D, and down to G, and across to F. And have we visited them all? I think we have. I think we're finished. So that's it. We can go B, E, C. Then we just use these vertical zigzags to finish off. And we have visited every dot vertex on the network. So that one's finished. So that's all of question 5 done for you. But have a look at the book's answer, because they might have different answers, and try and trace out that path and make sure you understand how they got that. So there's a number of different answers we've listed here. It'd be worth your while just tracing them out on the diagram, just making sure you understand them and you understand why they're a Hamiltonian path. All right, now question 6, we did the Euler circuits previously. This time we're doing the Hamiltonian cycle if they exist, okay? So maybe you cannot do a Hamilton cycle, and that's possible on a network. There are some networks that are shaped such that you cannot do a Hamiltonian cycle. Now, unfortunately, sadly, there's no vertices rule. Remember with Euler circuits, we had that rule that if the degree of all the vertices was even, which I think this one was when we did Euler's, then you can do a circuit and get all the way around using all the edges, but you did have to visit, I think we visited vertex B a couple of times and that. And remember, on a Hamiltonian, you can't visit a vertex a couple of times. So number A, unfortunately, there's no rule. Hamilton doesn't have rules like Euler did. That's why I love Euler and his little formulas. So a Hamilton cycle needs to visit all the vertex lessons, but we can't visit any vertex more than once. We can't repeat visited it. Now, on this one, 6A, there is no possible Hamiltonian cycle. If you try tracing out, you can try go around the big outside one first like we did with Euler, but you come back and visit B again. Okay, so whatever you do, you'll come back and visit something more than once, and that's not allowed. Now, the thing is, to do a Hamiltonian, you need a lot of crisscross kind of zigzags in it, which this one doesn't have. And that's a property of that which makes it kind of impossible to do a Hamiltonian cycle. Now, this one here has a lot of zigzags and crossovers, so it's pretty likely we should be able to do a Hamiltonian cycle for that shape. Okay, so the strategy is to get to all of these multiple zigzag crossovers in the middle as soon as possible, because Z shapes, they allow us to do a lot of things. So if you go from like H to G, you can get to F, and then to E, then to D, then up to C. So all the zigzags make you zigzag visiting a lot of points really quickly. So a lot of those vertice dots. Now, so the hint is, we'll give you a hint, start with A, B, C, and then after that do zigzags, and you should be able to get an answer. If you want to get the book's answer, you need to start with H, A, B, and then start doing all these sort of crisscross zigzags, all right? So go for either one, A, B, C to start off with, or H, A, B if you want to, and we'll leave you to finish that one off to do a Hamiltonian cycle. So if you're starting at A, of course, you've got to make sure when you finish, you end up back at A. And if you're trying the book's answer one, if you're starting at H, you've got to remember you need to end up back at H when you finish, and you need to make sure you've only been to each vertex dot once during that whole journey. All right, question 8. Identify which of the graphs from question 7 have a Hamiltonian cycle. and identify the Hamiltonian cycles that are found. Now, these are the ones from question 7. They were the network drawings we had back in question 7 in exercise 5.4. And again, unfortunately, there's no Euler rule, so we can't check these out first and see whether or not it's a waste of time trying to draw a Hamiltonian cycle because one doesn't exist. So there is no little rule. You have to go through the pain of trying to draw them, and if you get really frustrated and think, no, I can't draw one, well, then you give up and you say there's no Hamiltonian cycle. So look, to make things a little easier for you, we'll tell you that 3 and 4, even though they've got lots of zigzag crossovers, and you'd look at these and think they're much the same as 1 and 2, they should have Hamiltonian cycles as well. When you try these out, they don't have Hamiltonian cycles. The main problem, see how this H is off on its own? You can't go and visit H and then go anywhere else. So as soon as you've got these single ones like this, that's trouble, and that means you can't do a Hamiltonian cycle. So this one has this single one at G, so sure, we can get over and visit G, but to get back again, we've got to go and visit F again. So that's going to kill it. That's end of story on that one. That's a deal breaker. And this H up here, we can go and visit H, but we don't have a link to go off and visit somewhere different. We'd have to go from A up to H, then we've got to come back to A, and we visited A for a second time, and that's not allowed. So as soon as you have these single ones off to a vertex, like these two drawings have, that's the deal breaker, and you can't do a Hamiltonian cycle, all right? But these other ones, you should be able to do Hamiltonian cycles for, and we'll leave you to work out what the Hamiltonian cycles, where you can visit each vertex once and get back to where you started, what they are for those two, 8.1 and 8.2. All right, let's look at question 11. I think we've only got 2 more questions to do. In the following graph, this time we'll get Hamiltonian path. So I want to visit all the vertices, but we do not have to start and finish at the same place. And they tell us we have to start off traveling. We have to commence, so we've got to start off going from B to E. All right, so we don't get to pick. They've told us we've got to start off from B to E. So we'll start off from going from B to E around here on this one, all right? Now, because we started at B here, we're not allowed to visit B again. So that means you won't be able to use this path C to B, and you won't be able to use this A to B path. Both of those now are out of bounds. We can't use them because we've already started at B and we've been round to E. So we can't use that path or that path there, all right? So from E, we'll leave it to you to figure out the 2 possible end vertex points. So you could go maybe up to A and then down to D, or you could choose to go up to D and then go somewhere and finish and make sure you visited all the vertices, okay? So you got, once you hit E, you've got 2 choices basically. You go this way and finish off, or you go that way and finish off. Or you could even go around that way and then come down to D, okay? So you've got a few ways of finishing off there, but there's 2 vertex points where you'll finish. Now, the next one's similar, E to A. So we've got to start off at E and we have to go up to A, okay? So that's what they've told us for that one. Now, because we've started at E for the path, we cannot visit E again. So that means these 2 looping sides, which both lead to E, these ones here, we can't use those at all. And we also can't use the D to E one because that would take us back to E for a second time. All right, so that sort of gives you a clue that you're only using these 4 in here to finish off. So another clue on that is that when we get to A, we've got 2 choices. We can either go straight ahead up to B and finish off, or we can take a right-hand turn and go to D and finish off visiting all the vertices. So you can turn right and then you do D, C, and B, so you're finishing at B, or if you go straight ahead, you're going to go B, C, D, and finish at D, all right? So that's sort of how those ones work. So the answer is the 2 possible endpoints are going to be B and D, but we'll let you try and work out the 2 possible endpoints on part A. Okay, question 15. Use the following complete graph to complete the table. Hamiltonian cycles. So we want to go around and start at A and finish at A. Okay, so they've done one for you. We can go A. Oh, we can just go in alphabetical order. We can go A, B, C, D, A. So we can just go all around the outside and we'll visit all of those vertex dots and we get back to A where we started. All right, now what is the next one we should try? Well, it turns out we'll give you a little clue on this. This graph is very connected because of the crisscross X shape in the middle. And that means that's why they've got 6 down here, 6 possible Hamiltonian circuits we can do that all start, because the question did say we have to commence at vertex A. So we've got to start at A on these. All right, so there should be many Hamilton paths. Now the next one is actually, see how we did AB here and went to C? We're going to do AB again, but we're going to go somewhere different. So we did AB and going to C. So let's go somewhere different. We'll go AB, but this time we'll go down to D. So I need to get my little drawing pen here, which I haven't used for a while, but we'll give it a go. So this time we're going down to D. All right, so we're going A, B, down to D, then we'll go up to C. And then after that, we just go back to A and we've finished our loop. So that's the second one. You can go A to B and then you've got 2 choices. You can go up to C and finish off, or you can go down to D and finish off. So for the next 2, you're actually doing now, you've done AB, now you're going to do AC. So what we're going to do is we're going to go A up to C. Now when you get to C, there's 2 choices. We can go A to C, and we can turn left and go B, D, A. So in here you can do B, D, A if you go that way. Or we can go A to C and we can turn right. Okay, last time we turned left, this time we go A to C and we turn right. So we can go A to C, then to D, then up to B, and then down to A. So this one we go D, B, A. So this one's the other way around. We're doing D, B, A. And the only reason we can do all these is because that is a really highly connected network with that crisscross X in the middle of it. All right, we'll leave you to do the other 2, but I think you can start to figure out, AB, 2 of them, AC, 2 of them, what might come next and have 2 of them. And remember, you always need to finish at A. So we'll leave you that to finish that one off. Now, are other Hamiltonian cycles possible? Yes, we can start at any of the other letters. So you can start at B, and I think you can do 6 of these as well. So you can start at B. Because this is so interconnected with that X in the middle, you can start at B or other letters and do lots and lots of Hamiltonian cycles in there. So this is a really good network for doing Hamiltonian cycles. Now that's it. So you need to finish off. So we've covered exercise 5.4, pages 216 to 217. If you're in my class, if you're in another class or school watching this, that's fine. Just do the questions which your teacher has set for you on Hamiltonian Paths and Cycles. So we need to do questions 5, 6, 8, 11, and 15. Now several of these have been done in the video, so that's really good news. Yeah, and several of them you have hints for, and you just need to finish off. And gee, Hamilton Island is a nice place, but I couldn't afford to live there. Can hardly afford to go for another holiday there, actually. But when you want to have a house on your own private island, never give up on your dream. I mean, if you're on a budget, maybe this will be the house you have on an island. It's still nice and secluded and peaceful at night time, with the lap, lap, lap of the sea, seeing you asleep. And speaking of seeing you, we will see you in the next lesson.